Alright, IM2 9.1, radius, diameter, and the circumference. Objective students or Buckingham team players will be able to identify and use parts of a circle and find the circumference of a circle. So we got some boring vocabulary to do here, but you'll see in class why being familiar with some of this stuff is going to be very helpful. So let me just go through this real quick. Circle, this is simply a set of points in a plane equidistant from a given center. A given point called the center. Sorry, I got ahead of myself there. So here's the center. Here's all the points that are all equidistant from the center, and it makes a circle. We name circles by their center. So for example, this circle down here is a K, so we'd call it, we'd write a little circle, and then write K. A chord. This is a segment with endpoints that are on the circle. A radius, this is any segment with endpoints at, there should be an at there, at the center and a point on the circle. So a radius just goes from anywhere on the center to the edge of the center. So let's draw one in here real quick. That's a radius because it just goes from the center to the edge of the circle. And then we have a diameter. This is a chord that passes through the center. So the diameter is a chord because a chord just has two endpoints on the end, and the diameter is a chord. Alright, so why is that important? Well, because sometimes we're going to be asked to name a circle, identify a radius, a chord, and a diameter. So let's do that real quick. If I want to name this circle, like I said before, this circle is all revolved around the center K, so we would just call it circle K. I know it kind of looks like OK. Identify a radius. Well, we got lots of radiuses in here. I'm going to say center. Okay. Radius. The radius, we could say, well, KO is a radius. We also could say NK. We also could say KQ, and there's more there too, but you get the idea. A chord. Where's a chord here? Well, a chord, remember, has to have an endpoint on the circle and another endpoint on the circle. So NO here is a chord. And there's some other ones in there too, but that's all I'm going to point to for now. And then finally the diameter. The diameter has to go, it's a chord, so it goes all the way through a circle and it has to go through the center. So RP is the only chord that we have, or the only diameter that we have in this circle. So I would say RP. Okay. So let's play around with this a little bit. We didn't really get into the math of this, but we should know that a diameter, if a diameter goes through the whole circle and a radius just goes through half, then the diameter equals 2 times the radius, or you could say the radius equals 1/2 the diameter. Either way, that's how they relate. So, circle A has diameters DF and PG. And it says if DF is 10. So if this is 10, what's DA? Well, that should be easy, right? It should be exactly half of 10. DA would have to be 5. Okay, I think you could do B and C on your own, so why don't you guys go ahead and give that a try. Pause the video, and then record your answers, and then unpause it when you're ready to move on. Okay, so if PA is 7, PA is a radius, PG, which is a diameter, would have to be twice as much, so it would have to be 14. If AG was 12, AG is a radius, then LA would have to also be 12. Okay? And I want to point out something. This if here means that obviously DF can't be 10 and PG be 14, right? They have to be the same if they're in the same circle. So we're giving this if here to say each time, hey, this is a new set of circumstances. All right. Let's play example number 3. It tells us the diameter of circle A is 10, circle B is 20, circle C is 14. Find XB. So XB, oh, and BY. So XB is here, and BY is here. All right. Well, we're going to have to use a little bit of the old segment addition postulate. but it's not that big of a deal. It's actually pretty easy. What I'd say we should do is we should kind of mark all these as the radiuses, because that's kind of more what we're drawing here. We have a radius, we have a radius, we have a radius, we have a radius. So, circle A, the radius would be 5. Circle B, the radius would be 10. And circle C, the radius would be 7. Okay, well we could fill that in. Circle A is 5, so that means that this distance right here is 5. Circle B, the radius is 10, so that means that this distance here is 10. And also, that distance there is 10. And circle C's radius is 7, so this distance here is 7. Well, this makes it pretty easy to calculate, actually, the distance of XB and BY, because if this whole distance is 10 and this distance is 5, then this distance is 5. So we can say that XB is 5. If this whole distance is 10 and this distance is 7, then we know this distance has to be 3. So we could say BY is 3. Alright, let's go to the next page. Alright, so now let's talk about circumference. Circumference is just a fancy word for perimeter of a circle. It's just this distance around a circle. So, distance around a circle. And we have a beautiful relationship between circumferences and the diameter, or the circumference and the radius. And that is that the circumference always equals this weird number pi times the diameter. Or, since the radius is half of the diameter, we could say 2 times pi times the radius. We'll find yourself probably using this formula a lot more, but you can use either one to find the circumference, or to work backwards and find the diameter. What's unique about pi, we've talked about this before, but pi is, and I shouldn't say equal, I should say it's approximately 3.14159, and these numbers go on and on and on forever with no pattern. So it's pretty intense. So since this number just goes on and on and on for decimals with infinite decimals, and it's just really complicated, we just use this little symbol pi instead. And occasionally we plug in our calculator to actually get a approximate decimal answer, but for the most part we're just going to leave things in terms of pi unless it says otherwise. So, for example, it says find the diameter and circumference of the circle. Here's my circle that has a radius 2. Diameter is going to be easy, right? Because we said the diameter is simply twice that of the radius. So the diameter in this case is just 4 inches. Well, once we have the diameter, we pretty much have the circumference as well, because all we have to do is put the diameter in front of this pi symbol for my circumference, because the circumference is pi times diameter, so my diameter is 4 times pi inches. And I can leave it just like that. If they ask for it rounded to the nearest decimal, I could plug this in my calculator. 4 times pi, it's going to be 12 point something. But otherwise, I just leave it exactly like that. It makes things nice and easy. So, I want you to try practice number 4. It says find the circumference and the radius of this circle. So go ahead and do that one on your own. Alright, so the radius would be half of the diameter, so it's 1.5 centimeters. And the circumference is just the diameter times pi, so 3 pi. Alright, let's move on. Find the exact circumference of circle P. Okay, interesting because they don't give us the radius or the diameter here, but they do give us a little right triangle. Actually, they give us a rectangle, but all we really need is this right triangle here, because this distance here is a diameter. It goes from one end of the circle through the center to another end. And this 5, 12 here is a hint. That is one of our Pythagorean triples that we learned about last chapter, so we should know what this distance is here. We should know that this diameter is actually 13. 5, 12, 13 is Pythagorean triple. If you don't remember, all I did there is 5 squared plus 12 squared has to equal something squared. You could solve this, you end up with it has to equal 13. This is just a triple that I have memorized, and hopefully a lot of you guys have memorized as well, because it certainly makes your life a lot easier. So, if we know the diameter is 13, the circumference should be easy. The circumference will equal 13 pi. centimeters. Boom. All there is to it. All right. Another example question here. Suppose the circumference of a circle is 6 pi. What is the radius? All right, so think about it this way. We know the circumference equals 6 pi. We also know the circumference always equals 2 times pi times the radius. I just got that from my formula right up here. That's all. So, if that's true, suppose the circumference of the circle is 6 pi. What is the radius? Well, we could just solve this. This is just a real simple equation. I have a variable r. It's just simple algebra. I could divide by 2, and I can divide by pi as well. 2 pi. Pi's cancel out. Pi's cancel out. 2's cancel out. 6 divided by 2 is 3, so 3 equals r. So the radius is 3. That's it. They didn't give us units there, so just 3 units of some kind. So, practice 6 is a similar question. I want you to try it on your own, so you're going to have to pause the video. Suppose the circumference of a circle is 8 pi. What is the diameter? Go ahead and give that a try on your own. All right. So, you got your circumference is 8 pi. The diameter has to just be this number right in front, right? This is just the diameter times pi. That's how we get circumference. So this is your diameter. So the diameter is 8. All right. So to close off, I want you guys to read through this summary. And then through the Ed puzzle, I want you guys to be leaving a question and filling in your summary there for me. And that's how you're going to earn full credit for these notes. All right, I'll see you guys in the next video.